So this is question 2. Question 2, we are told to solve the given initial value problem. Now there is an initial condition here. We have two initial conditions, this and this. So the first thing is you're going to find a general solution of this non-homogeneous differential equation. After finding that, we would implement the two initial conditions that were given. Now when you implement the two initial conditions, you do not have a general solution anymore. Instead, you obtain a particular solution. So let's start by writing down the differential equation we're given. The differential equation we're given is 2y prime prime plus 3y prime minus 2y equals 14x squared minus 4x minus 11. Anyway, to find the general solution of a non-homogeneous differential equation like this, the general solution should be of this format: y equals yc plus yp. So where yc is the complementary function and yp is the particular solution. So to find yc, all we need to do is we solve the associated homogeneous differential equation. In other words, the first step is to find yc. So to find yc, we solve 2y prime prime plus 3y prime minus 2y equals 0. To solve this, the first thing is you find the auxiliary equation. The auxiliary equation here is 2m squared plus 3m minus 2. Like we said in the previous videos, that you replace the y with m equals 0. And then when you solve this, we obtain two distinct solutions. m1 equals minus half and m2 equals 2. So since we have distinct solutions, so that implies that the complementary function is going to be c1 e to the power minus half x plus c2 e to the power 2x. Now that is your complementary solution. Now to find, so the next thing is we want to find yp. We want to find a particular solution. So we're going to find a particular solution using the method of undetermined coefficients, but the approach we're going to use is the superposition approach. So we are using the superposition approach. So you know there are two approaches you could use. You could either use the superposition approach or you could use the annihilator approach. The two of them, they are still under method of undetermined coefficients. So but then for this video, we're going to use a superposition approach. So for the superposition approach, we need an assumed form for the particular solution. Now how do we obtain the assumed form? It depends on what we have in the right hand side. Now in the right hand side, what we have here is a quadratic equation. So we're going to assume that our yp is quadratic. So assume that yp is quadratic. So that's a squared. So you write it in full: ax squared plus bx plus c. Now at this stage, you want to confirm that all the terms you have, they do not have a twin in the complementary function. So when you compare the two of them, they don't have a twin. So since they don't have a twin, for this yp to be a solution of this differential equation, it implies that when we substitute it into here, we should get this. So I'm going to find, I already have y, I want to find derivative and the second derivative of that. So in a bit to do that, so we have yp prime to be 2ax plus b, and then yp prime prime, that's going to be 2, is going to be 2a. So the next thing we want to do is we want to substitute all this into the differential equation. So we have 2y prime, so that's 2 times y prime prime, which is 2 times 2a, plus 3 times yp prime, which is 2ax plus b, then minus 2 times y, that is ax squared, plus bx plus c. Now equals the right hand side. So that is minus equals, let me write that in red, equals 14x squared minus 4x minus 11. So all I want to do is I'm going to simplify the left hand side here and then begin to compare coefficients. So let's simplify that. So 2 times 2a, that is 4a, plus 3 times 2a, that is 6a, 3 times b, that is 3b, then minus 2ax squared minus 2bx, then minus 2c. So let's leave this for now. So when we do all this, let's collect like terms. So we'll put all the constants on one side, and then all the x on one side, and then all the b's, I mean all the x squareds on one side. I'm trying to collect like terms now. So my constants are 4a plus 6a plus 3b, and then the other constant is minus 2c. Then plus the x term I have here. This is my x term. This is my x term here. And then the coefficient is minus 2b. So I'm going to write plus x. So that'll be plus x into minus 2b. And then the x squared term is this, while minus 2a is the coefficient here. So I'm going to write plus x squared into minus 2a. Anyway, when we simplify this, you have 10a plus 2b minus 2c plus, now what we have for that side is plus minus 2b into x, then plus minus 2a into x squared. Now this equals, so what we have here is, the constant we have here is minus 11. I'm just going to write that normally, minus 11. Then the next one we have is plus minus 4 minus 4x. That's the next one we have, plus minus 4 times x. And then the next one is plus as 14 times x squared. So at this stage, all you want to do is just compare coefficients. So compare coefficients. The constants we have here, they are this, and then the constants we have here, they are negative 11. So comparing coefficients, so we have 10, this is 10a, so we have 10a plus 2b minus 2c equals minus 11, and then we have minus 2b equals minus 4, then we have minus 2a equals 14. So that's what we get. And then when we solve this whole thing, we have a equals minus 7, we have your b to be 23, and then your c would be negative 43. That's what we're going to have for our ABC. So now, since we have our a to be this, and b to be this, and c to be this, so we substitute them into here. So we have a, we have b, and then we have c. So therefore our yp equals minus 7, after substitution, minus 7x squared plus 23x minus 43. So we now have our yc, that's the complementary function. So we have our yc to be this, and I already have our yp to be this, and we know that the general solution should be the sum of the complementary and the particular solution. So therefore y, which is equal to yc plus yp, equals our yc from above is c1 e to the power negative x all over 2 plus c2 e to the power 2x, then plus yp, plus, that's minus 7x squared plus 23x minus 43. So this is our general solution. Now the next thing is, this is the general solution. So the next thing is we want to implement the initial conditions that we're given. That is, when x is 0, y is 0, and when we take derivative at 0, the answer we'll get is 0. So let me start by implementing the first one. It says y of 0 equals 0. Now y of 0 equals 0 is, so that is y is 0 when x is 0. So that's going to be c1 plus, when this is 0, this goes to 1. So this is going to be c2. This is 0, 0 minus 43. So we have one equation there. And then when we take the derivative of this whole thing here, we're going to have, we'll have minus c1 all over 2 e to the power negative x all over 2 plus 2c2 e to the power 2x minus 14x plus 23. So this is the derivative. But then the initial condition we're given above is that y prime as the value of the derivative at point 0 is 0. So that is y prime is 0 when x is 0. That is minus c1 all over 2. This goes to 1. When x is 0, it goes to 1. This also goes to, it goes to 1 because 2 times 0 is 0. So e to the power 0 is 1. So plus 2c2. So this is what we have when we're trying to solve this. Then minus plus 2c2, then plus 23. So now when we pick this and we pick this, what we get is, so this one comes to this side. So we have c1, so that's the new one, and we have c1 plus c2 equals 43. And then this one comes to this side, so it becomes minus c1 all over 2 plus 2c2 equals minus 23. So we solve this simultaneous equation, and then when we solve the simultaneous equation, what we have for c1 is going to be 218 all over 5, and then our c2 would be minus 3 all over 5. So that's our c1 and c2. And then since we know this to be the general solution, so I'm just going to pull this down. So we have our y, the particular solution is going to be c1 now, which is 218 over 5, 218 over 5, e to the power negative x all over 2, plus c2 as minus 3 all over 5, e to the power 2x, still writing the same thing. Then the next one is the particular solution, minus 7x squared plus 23x minus 43. Now this is the particular solution of this lovely initial value problem. And that completes the problem.